Hello everyone, how's it going? My name is Dan the Tutor. In today's video, we're going to talk about how to graph logarithmic functions in algebra. So I guess the first thing I'll show you, I'm just going to show you what the graph looks like. So any logarithmic function is going to look something like this, where there's going to be a vertical asymptote at the y-axis or at x equals 0. Logarithmic functions are famous for having their vertical asymptotes. Now, by the way, this function here could be log base 2 of x, could be the common log, which is just log of x, or log base 10 of x. This could be the natural log of x, which is ln, or log base e of x. It can be any logarithm. It really doesn't matter. They all look something like this. Now, one thing you should know is that we could have a shift to the log function. If you have a shift, like let's say you have log base 2 of x minus 2 plus 5, this is a shift of 2 units right and 5 units up. And that's because the x with the minus 2, the x is always the opposite of what it looks like. So even though it's negative 2, it is 2 to the right. And then it's 5 up because of the plus 5 at the end, and you don't flip the sign on that one. So for instance, if I go back to my original function and I plot a new one, 2 to the right and 5 up, maybe my graph looks something like this now. And now I have a vertical asymptote over here shifted 2 to the right as well. So that's just a quick example. And one more thing you need to know is if we have a reflection. Reflections look something like this. If it's an x-axis reflection, then the negative sign is going to be in front of the logarithm like this. And an x-axis reflection would look like this. First of all, the asymptote's still at 0, but now it's flipped so it looks like that. And then if we have a y-axis reflection, that would be where the negative sign is actually next to the x itself. And that graph would look something like this. Still the same vertical asymptote on 0, but now the graph is going that way. And yes, you can have a double x and y-axis reflection, but the negative sign would need to be in both places, negative log of negative x. But that's specifically for transformations, which of course are important to know, but you don't always have transformations. But one tip I will give you for transformations is that you should always do the reflections first, and then you do the shifts. That's a good principle that will help you get the right answer for transformations. And then one more thing I want to say before we start plotting some of these. If you want to get the best logarithm graph possible, you need to plug in some points. And there's 2 points that are going to work for any logarithm, and that would be this. If I have log base a of x, where a can be any number, it can be log base 2, can be log base 5, can be log base 10, whatever, then in my xy table, I will always have these 2 points. 1, 0, and a 1. And we'll look at some examples of how this looks in practice, but just take my word for it, this is always going to be the case. So for the first one we're going to graph today, it is y equals log base 3 of x plus 1 minus 2. So first of all, I notice that there's going to be a shift here. The shift is going to be 1 to the left and 2 down. And I know that because of the plus 1 and the minus 2 here. There's no reflections, so that's nice. And then if I want to pick my points, here's what I would say. First, xy table. I know for sure I have the points 1, 0, and a 1, where a in this case is 3, so I'm just going to fill that in real quick. So these are my points, but remember these points are shifted 1 left and 2 down. So to demonstrate that, I'm going to draw the transformed ones off to the side like this. 1 left is going to change the x values, so now they're 0 and 2, because 1 left is minus 1. And then for the y values, 2 down, it's negative 2 and negative 1. And hopefully that makes sense to you. So now I can graph this. First, that asymptote is going to be shifted 1 to the left. I can't shift an asymptote up or down, at least a vertical one I can't. So what I'm saying is the vertical asymptote is now at negative 1. Right here, and I have the points 0, negative 2, which let's say that's this point right here, and then I have 2, negative 1, which let's say that's right there. And if I want to draw the logarithm, I just have to draw a line that connects the dots and avoids the asymptote. So it would look something like this. Okay. And there we go. There's our answer. You don't need more than 2 points unless your teacher says so. But this is perfectly fine for me. Now let's do another one. Let's say I have y equals negative log base 4 of x minus 5. So for this one, I noticed 2 things. Number 1, based on the position of that negative sign, it will be an x-axis reflection. And I also know because of this minus 5, we are going to be shifted right 5. Now I'm going to do my table of values, x, y, 1, 0, and a, 1. In this case, a is 4 because log base 4. So that just goes there. But remember, it was shifted 5 to the right. And because of the x-axis reflection, I'm going to flip my y values. X-axis reflection always flips the y values. So in other words, flipping the y values first, it would be 0 and negative 1. Luckily, 0 just stays the same. And then I have to shift it right 5, which is going to only affect the x values. 5 plus 1 is 6, and 5 plus 4 is 9. So these are the points I have. If I want to graph this, I know I'm going to have a vertical asymptote here at 5. And then I have to plot 6, 0, which maybe that's like right here, and 9, negative 1, which maybe that's down here. So this was 6, 0. This is 9, negative 1. And again, if I want to plot this, I just have to connect the dots while following the asymptote. So it will look something like that. And there we go. There's another one done. Now let's see if you can get this last example without me. It is y equals 2 log base 6 of negative x. And I know we haven't talked about this 2, like what does this 2 do? I'm just going to tell you what the 2 does is you need to multiply your y values by 2. And it doesn't matter if you do that before the reflection or after the reflection, as long as you do it before the shift. And honestly, we don't even have a shift here, so that doesn't matter. So go ahead, give it a try, and hopefully your answer will match mine. Okay, so here's the solution. First, I noticed there is a y-axis reflection this time because of the negative x. There is also no shift, which is nice. And then if I want to do my x and y table, it is 1, 0, and a, 1, where a is going to be 6 because that's log base 6. So now with the new one, the transformed one, first I said I was going to double my y values, and that's true. Now it's going to be 0 and 2. Then I have a y-axis reflection. Y-axis reflection actually flips the x values, so it's going to be negative 1 and negative 6, like that. And there, I have my points. I'm ready to go. I'm going to plot this thing. Since there was no shift up, down, left, or right, the asymptote is still at 0, so that's nice. Then I plot my points, negative 1, 0 here, and negative 6, 2. Maybe that's somewhere over here. So negative 1, 0, and negative 6, 2. And then just to plot this, again, following the asymptote, we're going to have a graph that looks like this. And there we go. That's all the examples I wanted to look at today. If you do have any questions, please post them in the comments. Thank you all for watching. I hope you have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.